Section 8.3, Law of Cosines. I went ahead and started you off with the formula already on the page, right? Because this formula is a little bit more involved than law of sines, right? But I do want you to notice the a squared equation has a cosine angle A at the end, the b squared has angle B at the end, and c squared has angle C at the end, just to kind of point that out, right? The other thing I want to point out is that it's really important that you use correct order of operations here. You always multiply before you add or subtract. So the multiplication is after the minus sign here. 2 times b times c times cosine A. All of this needs to be multiplied together before you start adding and subtracting. The tendency is to go ahead and subtract 2 times b times c, and so you got this solution, and then you multiply that times cosine A. Okay, incorrect. So make sure you're multiplying 2 times b times c times cosine A before you do any subtraction. All right, law of cosines is used to solve two different types of triangles, and those are the side angle side and the side side side. So we're going to use to solve side angle side and side side side. Right? So this is an alternate to law of cosines. You're going to notice when we draw these triangles out that law of sines cannot be applied here. Right? So if we run into some given information and we can't use law of sines, we are going to have to use one of these law of cosine equations. So first, side angle side. So I'm just going to draw a random triangle here. So if we know this side, and then traveling clockwise, right, we're going to know the next immediate angle and the next immediate side. So in a side angle side triangle, the angle we know is always in between the two sides that we know. So they're really easy to spot. Now, if we can't use law of sines. I don't know if you tried to check it out. We can't use this side and this angle because we're not given this side, right? And the two sides we're given, we don't know their angles either, right? We can't solve for this third side using Pythagorean theorem either because this is not a right triangle, so don't do that, all right? So we are going to have to start with using law of cosines, right, for when we start to solve this side angle side. And so we'll look at one of those problems. Right, then the other type is side side side. Okay, so obviously on a side side, we can't use law of sines either because we need an angle in order to use law of sines. Right, so let's go ahead and solve a few questions. All right, so solve the triangle. We're given B is 6, C is 3, and angle A is 70 degrees. So let me go ahead and draw that out. All right, so little b is 6, little c is 3, and angle A is 70 degrees, right? So it is really obvious, right? The angle we know is nestled in between the two sides that we know. So we obviously have a side angle side triangle here to solve. So if we're given little b, little c, and angle A, we have to use one of the formulas that has little b, little c, and angle A in it, right? So looking up here, which ones have little b, little c, and angle A? Well, there's only one that has angle A in it. So we're going to have to use the top one here. All right, so in the top one, let me go ahead and write it down. A squared equals b squared plus c squared minus 2bc cosine A. All right, we were forced here because There's only one cosine formula that has angle A in it. So if we know angle A, little b and little c, obviously we're solving for side A. All right, so I'm going to go ahead and plug the numbers in. So b squared plus c squared minus 2 times b times c times cosine of 70. Right here, it's very tempting because you know 36 plus 9 minus 36, right? But we need to multiply all of this together before we start subtracting it. Now your calculator is smart. Your calculator follows order of operations whether you intend for it to or not. So if you type this in as is, it will calculate this correctly. So 6 squared plus 3 squared minus 2 times 6 times 3 times cosine 70, right, is, oh, I did something wrong. What did I do? Oh, I put a decimal in there instead of a 2. So let me go fix that. All right, 6 squared plus 3 squared minus 2 times 6 times 3 times cosine 70. Let's try that. 32.68. Right. Now remember, this is what a squared is. Right. Now I'm not going to write down all those decimals, but I am going to calculate a on all these decimals. I'm not going to have any round off error. So a is the square root of that. Right. So I'm going to take the square root of 32.68. So second square root. Now remember how to pull the answer underneath the square root. Answer is down here at the bottom of the calculator above the negative sign. And it's in blue, so second. And then the negative will get you your answer on your screen. And then you get 5.71, okay, or 72. Let's do 5.72 there. So now I know little a is 5.72. Right? So now I'd like to solve for angle B. So I'm going to use the law of cosines that helps us solve for angle B. Okay, this will serve 2 lessons. First, using law of cosines again, and then explaining why there's only one solution. Okay, right now, having all 3 sides kind of locks in what those angles can be. But let's go ahead and solve for angle B here. Right? The only equation, the only law of cosines equation that uses angle B is the middle one. So I'm going to go ahead and write that down. B squared equals A squared plus C squared minus 2AC cosine B. Right? So I'm going to plug those numbers in there. 6 squared equals 5.72 squared plus 3 squared minus 2 times 5.72 times 3 times cosine B. Right? Now be very, very careful here. We need to solve this for cosine B. So what we need to do first, okay, move the 5.72 squared over, move the 3 squared over. But this minus 2 times 5.72 times 3 times cosine, that needs to stick together, right? And the way we undo this multiplication times cosine is division, right? So over here, I'm going to move these 2 first, right? I'm just going to plug it into the calculator. Okay, 6 squared minus 5.72 squared minus 3 squared. Gets me negative 5.7184. Right? So these are gone. So that's going to equal negative 2 times 5.72 times 3 times cosine B. Right? So now I need to solve for cosine B. So I'm going to divide by negative 2 times 5.72 times 3. right? So divide, if you just hit divide right away, okay, it's going to take the answer divided by. Now, we have multiple items down here in this denominator, so make sure you put them in parentheses. So start off with the parentheses, negative 2 times 5.72 times 3 is 0.1666. All right, so there's the decimal. Is this in the domain of cosine inverse? Right? To solve for angle B, we need a cosine inverse, both sides. So the domain of cosine inverse is also negative 1 to 1 because it's the amplitude of cosine. So this works, right? So in order to find angle B, I'm going to cosine inverse this decimal, right? So back to the calculator again. Cosine inverse, second answer, is going to give an angle of 80.4. Right? Now, is there a second solution here? Well, we just did cosine inverse. All right? Of course, there's a second solution is the answer. Right? So 80.4 about here, right? But the cosine is the x-coordinate. So I know the x-coordinate is 0.166, and then the y-coordinate can be whatever it needs to be. All right? So where else between 0 and 360 is the x-coordinate equal to 0.166? Well, it's on the opposite side of the x-axis. Right? This also has an x value of 1.166. Okay, the y value is negative. So how do we find it? Well, the reference angle is the same. Now, the angle, we're not going to use negative 80.4 because that doesn't make sense in a triangle. And so we're going to do 360 minus 80.4. Right? All the angles in the fourth quadrant here are between 270 degrees and 360 degrees, which is way too big for a triangle. So luck is on your side today, okay, or tonight. Because when we use law of cosines to solve for an angle, there is only one solution, okay, that's viable in a triangle. Of course, there's two solutions, but the second solution is going to be more than 270 degrees, right? So it's just not possible to stick that into an angle measure of a triangle. So we're only going to have the one solution, right? Law of sines was different because law of sines, both of its solutions we're in quadrant 1 and quadrant 2. And all quadrant 1 and quadrant 2 angles are less than 180. Right? Cosine has angles, positive angles in 1 and 4. But angle 4 angles don't work in a triangle. So only one solution each time. All right? So angle B, 80.4. Now, we have all three sides. We have two of the angles, so to solve for the last angle, angle C, we just need to subtract from 180. So I'm going to go ahead and do that. 180 minus 70 minus 80.4 is 29.6. All right, so double check it real quick for me. Is the smallest side across from the smallest angle? Smallest side. Smallest angle. Is the biggest side across from the biggest angle? Biggest angle, biggest side? Yes, it is. Right? So the spot check works here as well. Right? So good news, guys, whenever you use law of cosines to solve for an angle, only one solution. All right? So this triangle is solved. Let's try another one. I think I have three more here. Two more just blank triangles, and then one kind of word problem for you. So let's do A is 26, B is 32. Let's try that again. 32, and angle C is 110 degrees. So if I draw the triangle here and label accordingly, little a is 26, little b is 32, and angle C is 110 degrees. Right? So the angle we know is in between the two sides, okay? Quite clearly a side angle side here. So we need to use law of cosines here because we don't have anything to use law of sines to work with. So we're going to have to use the formula that utilizes little b, and angle C. Right? That angle is your big hint, right? Because the only law of cosine formula that has angle C in it is the bottom one. So I'm going to go ahead and use the bottom law of cosine formula. So I know C squared equals A squared plus B squared minus 2AB cosine C here. I'll go ahead and plug the numbers in. 26 squared, 32 squared, 2 times 26 times 32 times cosine of 110, right? So just type it in, okay, straight across on your calculator. Let your calculator do those order of operations for you. Here we go, 26 squared plus 32 squared minus 2 times 26 times 32 times cosine 110 gets 2,269.12. All right, but that's what C squared is. All right, so in order to get C, we need to take the square root of that. And so we get 47.6. All right, so little c is 47.6. All right, so just notice 47.6 is our biggest side. So angle C should be our biggest angle, right at 110, which makes sense because at 110, that's only leaving 70 degrees left for A and B, right? So A and B together is going to be less. So we should have the biggest side across from the biggest angle here. All right, so let's go ahead and solve for angle B again. All right, using law of cosines, we could solve for A or B. Let's go ahead and solve for B. So I'm going to use the B squared equals A squared plus C squared minus 2AC cosine B. It's a mouthful. All right, here we go. Where do I want to put it? Let's do it up here. All right, so plugging numbers in, B squared equals A squared plus C squared minus 2 times A times C times cosine B. Right. So remember, when we're solving this, we got to solve for cosine B. But we need to move these constants over first and then divide by this coefficient, if you will. So I'm going to do 32 squared minus 26 squared minus 47.6 squared. I'll go ahead and write that this time. Equals negative 2 times 26 times 47.6 times cosine B. Right? Why am I not adding this? Because this is really being multiplied. All of this is being multiplied times cosine B. So be careful here. Right? So let's do 32 squared minus 26 squared minus 47.6 squared. 19.17.76. I could have multiplied that together, but I started writing it, so I might as well go with it. All right, so now to solve for cosine B, I'm going to divide by all three of these terms here. Okay, by the -2, the 26, and the 47.6. So when I do the division, make sure you're putting all of these in parentheses. Okay, so divide, parentheses, -2 times 26 times 47.6 is 0.774. All right, so then to solve for angle B here, I'm going to cosine inverse both sides. And this is going to work, right guys? Because 0.774 is in the domain of cosine inverse. It's between -1 and 1, so this is going to work. Cosine inverse of the answer is going to get angle B to be 39.2. Let's go ahead and put 39.2 degrees. Now remember, the second solution for that, right, 39 degrees here. The other solution where the x value is 0.774 is down here, right? And so that angle is way bigger than 180, right? So we aren't going to use a second solution even though there is one. Right, 39.2 is the only B that's going to work in our triangle. So our 39.2, 110, so just subtracting from 180 will help me finish out solving this triangle. So 180 minus 39.2 minus 110 leaves me with 30.8. All right. So the smallest angle ended up being angle A. And that's good because little a, side A, was the smallest side. So it all works out. Right? Let's do one sine, sine, sine triangle. And let's do that. Then let's do this word problem here. So little a is 32. Little b is 46. Little c is 69. All right, so since we're given all three sides and none of the angles, we can't use law of sines, but we could use any of the three law of cosines, any of them whatsoever. Right? We just need to start solving for one of them and then work on the other two. So it really doesn't matter. I'm just going to start with A. Okay, so I'm going to use the law of cosines formula that has angle A in it. All right, which is this one, a squared equals b squared plus c squared minus 2bc cosine A. And then I'm going to go ahead and plug all my sides in there. So little a squared equals little b squared plus little c squared minus 2 times b times c times cosine A. All right. Now we've done this a couple times. All right. I like to subtract the constants first and then divide by the negative 2.6 or 2 times b times c. So I'm going to go ahead and do that on the calculator. All right. 32 squared minus 46 squared minus 69 squared is negative 5853. All right. So I'm going to write that down. So now I have negative 5853 equals negative 2 times 46 times 69 times cosine A. All right. I'm just moving this over, right? I'm moving this over, and subtracting it. Okay, so these are gone. All right, so now to solve for cosine A, I'm going to divide by negative 2 times 46 times 69. So negative 5853. Okay, the answer being divided by 3 terms here. So I'm going to put them in parentheses. Negative 2 times 46 times 69 is 0.922. So is law of cosines going to work? Can I cosine inverse both sides? Yes, right? Because this is between negative 1 and 1. So if I cosine inverse that answer, I'm going to get 22.8 equals 22.8, right, degrees. There we go, 22.8 degrees. Good. So 22.8 is across from 32. So this should be my smallest angle, right? Let's go ahead and do the bigger angle. Let's do angle C. That should be the biggest angle we get. So I'm going to use C squared equals A squared plus B squared minus 2AB cos C, right, to get that bigger angle. So let's plug our numbers in. Right, I'm going to move 32 squared and 46 squared over. Right, so let's do 69 squared minus 32 squared minus 46 squared and get 1621. Alright, and then to solve for cosine C, I'm going to divide by negative 2 times 32 times 46. Alright, so cosine C, 1621 divided by parentheses, negative 2 times 32 times 46, negative 0.55. Is this going to work? Right, can you cosine inverse this? It's between negative 1 and 1, right? This is the first time we've gotten a negative over here. But that is okay. Because remember, if cosine inverse has a negative ratio, that means that angle's in quadrant 2. And that angle in quadrant 2 should be our biggest angle, right? So more than 90 degrees. This is okay here, all right? So let's go ahead and cosine inverse this result, and we're going to get 123.4. Okay, so angle C, 123.4. Right, I was expecting a fairly large angle there, and we did, and we got it, right? Because since this was negative, I knew it was in quadrant 2. All right, so to solve this triangle, we only have one remaining angle left. And so in order to solve for angle B, let's go ahead and subtract from 180 there. So 180 minus 22.8 minus 123.4 is 33.8. Right. So the smallest angle is across from the smallest side, the largest angle is across from the largest side, and then angle B is there in the middle, right? So there's a lot of examples on law of cosines. Let's go ahead and do that word problem I was talking about. Okay. It's going to take a moment to write it down, but it is worthwhile. Okay. A plane Actually, you know what? Let me just fold this paper up and put it at the top here. Okay. So let's look at this problem here. A plane leaves airport A and travels 690 miles to airport B on a bearing of north 42 degrees east. So we're going to talk about how to draw that. The plane later leaves airport B and travels to airport C, 525 miles away on a bearing south 81 degrees east. Right? Find the distance from airport A to airport C to the nearest mile. All right. So we're going to leave airport A and we're going to go north 42 degrees east. So I'm going to draw a little dot here. This is airport A. So we're going to go north 42 degrees east. So that means from the north direction, heading north, we're going to veer east 42 degrees. So I'm going to draw an imaginary north line here. Right? This is going north and this is going south, but we're going to bear 42 degrees to the east. Right? So if I kind of rotate almost a 45-degree angle, right? This is the flight path that we're going to follow. Okay? So north 42 degrees east, and we're going to go 690 miles. So 690 miles away is airport B. So this side is 690. Okay? North 42 degrees east. So now the plane is sitting here in airport B. And from airport B, it's going to fly to airport C. Right? And it's going to travel on a bearing south 81 degrees east. So again, I'm going to draw an imaginary north-south line here. Right, so the plane is going to go south 81 degrees east. Right, so south direction, but rotating 81 degrees to the east is almost kind of horizontal here. Okay, so south rotating 81 degrees to the east is that bearing. Okay, and it's going to go, my scaling isn't here, but let's say airport C is here. All right, and then we know how many miles away from B to C. B to C is 525 miles. Right. So the question wants us to find the distance from A to C, not the bearing, right? This distance. So let me just call this X, right? We want to find this distance. So we have these two sides, and we have part of this angle here. So it looks like we have a side angle side that we need to solve, right? And a side angle side is law of cosines. So we have to figure out what this entire angle is, right? So using a little bit of geometry, okay, a north 42 degrees east bearing is equal to a south 42 degrees west bearing, right? North 42 degrees east is equal to south 42 degrees west, right? And not only that, just some geometry, our north-south lines are parallel. So if we cut that parallel line with a transverse, the alternate interior angles are equal, right? But just logically, north 42 degrees east is the same as going south 42 degrees west. All right, so I'm going to put 42 here. That means angle B, this entire angle B is 42 plus 81, right? Which gives us a total of 123 degrees, right? So I have a triangle with a side of 690, a side of 525, and this angle here at 123. Now, you know what? I think instead of calling this X, let's go ahead and call it little b, just so our letters line up with our law of cosines here. So what do we know? We know little a is 525. We know little c is 690. And we know angle B is 123 degrees, right? The 81 degrees bearing east plus the 42 degrees bearing west gives us a total of 123 degrees. And I want to find little b, right? So in order to find little b, let's go ahead and use the b squared equation. Oops, you can't see any of that I was writing. All right, let's go ahead and use the b squared equals a squared plus c squared minus 2ac cos b and plug our numbers in. All right, so b squared is going to be equal to 525 squared plus 690 squared minus 2 times 525 times 690 times cosine of 123. Right? So this one is the one where we don't have to move them over, right? We just multiply all this together and then take the square root. So the calculator will do the rest of the work for us. All right, here we go. 525 squared, 690 squared, I got a number in the millions here. Let me go ahead and square root it. And I got 1070.66. So little b, 1070.66. So if we were to round this to the nearest mile, right, like it says, we're going to say it's 1071 miles away. Right? So airport A is 1,071 miles away from airport C. And looking at the solutions, right, we did indeed get it correct. All right, so I hope you enjoyed, you know, a little bit of real-world application there with the bearings. All right, it's not complicated, right? A few things are. So that concludes 8.3. And I hope you have a blessed day.